Hello everyone. Today as a part of assignment 4, we are here to see NMD simulation of a protein in which we are given a list of 15 proteins wherein we will select a randomly uh, generated protein, download its database, then we will clean it and add water molecules, neutralize its charge, and then we will run its NMD simulation. So for that, first we will go to Google Colab. So here I have just written the name of the proteins and created a PDB list. So to check whether all the proteins are correctly copied. So for that we can see length into bracket. We can write PDB underscore list. Control enter. So here, yeah, so we have selected we have 15 proteins in this list. So to continue for selecting a random protein, we will give it as a comment and then we will import random. Then we will write random underscore protein is equal to, although the AI is giving us the syntax, we will continue writing PDB underscore list. Then we will say print the randomly generated control enter. So the protein which we have got is I1IV9. So we will copy the code of this and we will go to the RCSP website, which is the protein data bank, and we will enter the name, enter, and this is the protein which we have, crystal structure of single chain monoline. The classification is plant protein. It is a plant protein. Here the experimental data snapshot is given and the other informations are also given. So from here, we will select the download files and PDB format. So the file is downloaded. Then okay. Now we will go to VMD for visualization. So we will go to extensions, TK console, and here I have given the same, I'm in the same directory. So mol add, so sorry, mol new and the name, which was I1 tab PDB. So where is the, so here we can see that we have got this protein in the visualization box. Then we will go to graphics, representations, create repeat. We only want to see the protein. Okay. Protein. Coloring method, let's skip it to secondary structure. And drawing method, let's go to new cartoon. Apply. So here we can see that the middle one is the protein. The actual protein looks somewhat like this, and it is covered with some molecules. Okay, so now we will again go to TK console, and we just want a file having proteins. So we will select set cell into bracket, atom select top protein, enter. and then we will create its PDB file, cell, write, PDB. I'm giving the name new pro.pdb. Enter. So now I have created a new PDB file having just protein. So we will delete the existing file. By first we can see that the number of atoms here in the file total is 1645. So now deleting the file, mol delete all. So the file is deleted and now we will load the new PDB structure. So mol new pro.pdb. So here we have the new files, wherein we can see the number of atoms has been changed to 1564. So now PDB, we know that PDB file only contains the coordinates, but we need other details like topological files, angle present, bond parameters, etc. So for that, we need to create a PSF file for that. So to create a PSF file, we'll go to extensions, modeling, automatic PSF builder. So here we can see that for input files, we have our new pro.pdb and the output base name will be new pro underscore auto psf and .pdb. So we'll load input files, then we will have everything, guess and change the split chains. Then we will go to create chains. So it says that structure complete. Your structure is new pro.psf.pdb and .psf. Okay, here also we can see that it is created. Okay. We'll do mol delete all. And we will open our new files generated. So first we will load our PSF file, mol new to underscore auto psf.psf and mol red file to auto psf.pdb. So yeah, the new file is here with 3125 number of atoms. Okay. So now we need to add water. Why we are doing is to mimic the system as it is in the experiment. So for that, for adding the water, we will go to extensions, modeling, and add solvation box. So we will browse our files. So this is PSF and this is PDB. One. This is done. In the question, we are given that we need to keep our box padding as 20. So we'll give it 20, 20, 20. So here we can see that the output will be in the solvent.pdb and solvent.psf. So we will do solvent and the calculations will run. Yeah, the solvent completed successfully. And then we can see that around our protein, we have got this water molecules surrounding it. Okay. So now again we will delete our file. So it will be mol delete all, and again we will add the new file mol solved.psf and mol add file solved.ptb. Yes. So now, if we want to see where is the box padding, so we can write pbc get. So here we have got the coordinates of x, y, z and alpha, beta, gamma. So now we need to calculate their charge. So the charge of protein and the charge of the water. So for checking the net charge, we will create the cell. So set cell 1 bracket atom select dot A. Enter. Okay. And now we will do set cell 2 bracket atom select of this. Okay, the set is created. Now for calculating the charge, eval bracket dollar cell 1 get charge enter. So here we can see that for the proteins we are getting the charge of 5.000, and for waters we will have, it should be 0 as it is neutral. So yeah, it is 0.0. So now to neutralize this protein, we will go to extensions, modeling, add ions. Again, we will browse our file, solvent.psf. Open. Solvent.pdb. Open. Ionized, and as per the question, we are giving 0.5 mole and auto-immunize. So it's all done. So now again, we will remove these files and load our new files. So now again, we will check our charge, set cell 3, bracket, atom, select, off, and we will see for the whole system. Enter, eval bracket, charge, 3. Yeah, so 2.00 e raised to -6. So it is a negligible charge. So now the files are ready for the simulations. No, so again, we need to make some changes in the configuration file. So for that, we need to measure the center of the box. Matters cell 3. So these are the coordinates which we will prevent in the file. And again, we will do pbc get this files, these numbers we need to change. So for that, we will go to WinShape. Here, I have already uh, uploaded the files which we were given in the classroom. So minimize.conf and npt is already there. So from here, the files which we selected, we require pdb and psf. So these are our last files which we created, ionize.psf and ionize.pdb. And based on this, we will make some changes in the minimize.conf. And we will do this with console. So in this file, let us understand, this is known as the minimization file. The structure and coordinates are taken from the ionize.psf and ionize.pdb. The temperature is kept to be 300, and the output file will be given by output name as minimize, and it will have so many files for the restart frequency, dumping frequency, exit frequency, output energies, output pressure, etc. These are the forced file parameters which we have to give upon where our files is present. Then this we will also change, and this is the char parameters, and this have the small cutoff frequency and switch distance. Again, this need to be as it is. And here the Langevin dynamics is kept to be on for the NMD simulations. And here we'll make our changes. So the cell origin, we need to take it as this. Let's see. Okay, so the selection has been done. Now we will change our coordinates. It's 82, 87, 92, 82, 87, 92, and yes, the parameters are changed. Okay, so now we will go to next tab. Okay, so here first I need to check whether the NAMD module is present in this or not. So for that we will see module list. So no modules are present, so we need to load our NAMD module. So for that, module avail. So these are the modules available. So here we will select NAMD 3 for our CPU. So we will write module load NAMD slash 3.0B3. So it's taking a little bit of time. So the module is loaded. So again, we can check that module. Yes, so here we have got the module. So now I need to check where am I. Okay, so I need to go to my Scratchwork directory. So I go to cd. I'm in assignment 4, EWB. Okay, so this I need to copy paste. It is the same path because I have done this before. So save. Now we are ready to run our simulation. So we can also see what are the files present. So the files are ionized PDB, ionized PSF, and the minimize.conf. So for running, we will write the code NAMD3 minimize.conf. The simulation has started. So the simulation has started successfully. So that's all for this assignment.